Hello friends, this video on Environment Chemistry Part 7 is brought to you by examfear.com. No more fear from exam. So now we'll talk about the particulate pollutant. So particulate pollutants are minute solid or liquid droplets. The size can vary from 0.0 to micron to 500 micron. So if you see, this is my particulate pollutant. These are my small particles here. And with this, if you see the sun rays coming, you can still see the sun rays here, right? Because these particulates are reflecting the sun rays, and this thus you can visualize the sun rays. Correct? And they are generally present from the vehicle emission, smoke from the fires, from the ash in the industry, the algae, bacteria. All these are my examples of particulate pollutant. There are two types actually: the viables, where we talk about the living particulates, bacteria, fungi, algae are examples, and the non-viable. Non-viable have smoke, dust, mist, and fumes. So let's understand the non-viable now. The first one is smoke. Right? What is smoke? It is solid or mixture of solid and liquid particles formed during combustion of organic matter. So you have some organic matter, you burn it, you get solid or mixtures of solid and liquid particles. That is called smoke. For example, cigarette smoke. Then I have dust. Dust, if you see, the side diameter is more than 1 micrometer. So 1 μm is nothing but 10 to the power minus 4 meter. So write this. Right. And they are produced during crushing, grinding, and attribution of solid materials. If you see, this is my picture of a sand from the blasting site. You can also have the sawdust from the woodwork. If you go to a place where woodwork is going on, you will see the sawdust around the air. That is also a pollutant, right? It is dust. Also, if you go to cement factory or fly ash factories, you will see the dust. This is my dust storm. What you see in the picture. Other non-viables, I have mist. Mist are nothing but the dispersion of liquids in gases. This is my mist, right? Sometimes if you see the sulfuric acid, herbicides, pesticides or insecticides, whatever the farmer use, they also because liquids, right? So this is dispersion of liquids in gases. So I have some liquid droplets here and they form mist. Correct. Fumes are dispersion of solid matter in gas. These are my fumes. Solid matter in gas. So understand the difference between mist and fumes. When talk about fumes, I'm talking about dispersion of solid matters in gas, mostly in air. When I talk about mist, I'm talking about dispersion of liquids in gas. There's a difference. When I talk about mist, I'm talking about dispersion of liquids in gas. When I talk about fumes, I talk about dispersion of solids in gas. So what are the effects of pollutant? See, the effect is dependent on size. So some of the pollutants are so small, some are big, right? So it depends on the size, right? So all this airborne particles, dust, fume, mist, they are all dangerous to humans. All of them are dangerous, right? So if it is bigger than 5 micron, it will be blocked by the nasal passage. But if it is almost 1 micron, it will impact the lungs. This lungs will impact it if the pollutant size is about 1 micron. Right? So earlier lead used to be a major pollutant because lead used to be a part of, it was used as anti-knocking agent in the cars, in the automobiles, but now lead is not used with petrol. Without lead, the petrols are used in the car because lead causes so much pollution. Right? Lead also interferes with the development and maturation of RBCs, red blood cells, very critical for our existence. So it interferes with the development and maturation of RBCs. Now we'll understand the difference between mist and smoke. See, the only difference is the visibility actually. If you see the mist, you can see things. This is maybe even 20 meter or 10 meter. But if you see small fog, see, you can just see the road here, right? And what you can't do is you can't see anything. So the visibility is less than a kilometer. You can't see things which are 1 kilometer far from you, right? Then it is fog. And this is not fixed. It depends from country to country. I think for UK, they say it is fog even if it is not visible in 200 meter. So if you can see things, even if I have my liquid droplets here, that is mist. If you can't see things, right, almost blank for you, and you feel that you are in the middle of a cloud, then it is smog. That's the only difference between smog and mist, all about the intensity actually. Now we'll talk about a new term called smog. Smog is something smoke plus fog. If you see, so in the three pictures I have shown, the two are smog. The one, if you see the red ones, the normal ones, and they have fog. This smog is smoke plus fog, right? And they are the most common air pollution. And actually, you can't differentiate between smog and fog just by looking at it. But there's a huge difference, right? Fog is not harmful, but smog is harmful, right? So fog is harmless, but smog is harmful. See, just by looking, you can't tell which one is smog and which one is. And there are two different kinds of smog actually. We'll explain that two different kinds. The one generally has the red colors and the one has white ones. We'll talk about the different kinds of smog. Just understand that smog is harmful because it has smoke also as part of fog. But the fog is harmless. Correct? So as I told, there are two types of smog, classical smog and photochemical smog. Let's understand the classical smog. So this is also called sulfurous smog or London smog. Sulfurous smog because it has sulfur. I'll show you why, and that's why it has sulfur actually. And then why it's called London smog, because first it was in 1952 in London, and that resulted in loss a lot of human lives also. And this is generally found in cold and humid climate, and especially in the morning hours. Please note, in the cold humid climate, in the morning hours in winter. Correct? Cold humid climate, morning hours, winter. As I told, sulfur, so it is mixture of smoke, fog and sulfur dioxide, SO2. And the source is generally industrial and household fuels, because from there we get SO2. And since SO2 is there, SO2 has reducing property. This is also called reducing smog. So there are three names to this. Four names actually: classical smog, sulfurous smog, London smog and reducing smog. It has sulfur in it. The next type of smog is called photochemical smog, and mostly because of NO2. You'll see this. This is also called Los Angeles smog. Why? Because the first in Los Angeles, 1950. If you see the other smog which you talk about, the classical smog occurs in cold region, right? This occurs in warm, dry and sunny climate. And it occurs in the midday, not in the morning, right? In the summer season, where the solar radiation is high. Here solar radiation plays a critical role. Sun plays a critical role. It has almost red color, if you see, the reddish color, because of nitrogen. So it occurs because of photochemical reaction between unsaturated hydrocarbon and nitrogen oxides, which is produced by automobiles, factories, and this happens in the presence of sunlight. So the main constituents are ozones and oxides of nitrogen. And since it has NO2 and O3, so both have oxidizing property, so they are also called oxidizing smog, right? So this color is because of NO2. Let's understand the formation of photochemical smog, why it is formed. So when the fossil fuels are burned, you get variety of pollutants. The major ones are hydrocarbons and oxides of nitrogen. Sulfur also, but here since we're talking about photochemical smog, we'll talk about oxides of nitrogen and hydrocarbon. So the reaction that happens is, see, the typical reaction is I have NO2. It reacts with sunlight, it breaks actually. You get NO free radical and oxygen free radical. Correct. And this oxygen free radical will combine with O2 to gives O3, ozone. And the next will be this NO free radical which I have got here, will combine with this ozone to gives NO2 and oxygen, and this NO2 will further be used. So this is a delicate balance we have, right? So nitrogen dioxide breaks into NO free radical and oxygen free radical, and then you get ozone. This two reacts and gets again NO2. This happens, this keeps happening, it's okay situation, right? And this is because of which you get the brown color. NO2 gives the brown color air. This is the okay situation, there is no harm in this. But the moment you put hydrocarbons here in this, the unsaturated hydrocarbon that is from the unburned fuel, it causes problem. What is the problem? So this ozone which I have got, this O free radical, it reacts with hydrocarbon and it forms these kind of substance, RCO, or it forms RCOO free radical. This is called peroxy free radical. Peroxy free radical. Correct. So this peroxy free radical, it will react with oxygens, NO3, etc. NO also in the atmosphere. And they form harmful compounds, formaldehydes, acrolein, organic hyperoxides, PAN, that is peroxyacyl nitrate, all these it will form. Let's see the reaction. So this guy is my culprit and this guy will react. So I have this guy. So let me react this guy with hydrocarbon. You can react with a lot of stuff. Let me react this guy with hydrocarbons. So it can form ketones. Or it can form acrolein actually, yeah. Single bond CH. Yeah, it will form this acrolein. It's all harmful actually. So you see, if this guys react with oxygen, it will form this free radical and ozone. Correct? So the ozone concentration will go up. Or if it reacts with my peroxy free radical reacts with NO, it will again form and NO2. Or if it reacts, this guy reacts with NO2 now, peroxy free radical. So it forms PAN now. This is called PAN. This is toxic. Correct? This is peroxyacyl nitrate. And this excess of PAN and ozone, these are harmful actually. These are harmful. So this is what happens. I have my NO2, it breaks into NO and O, and this is the delicate balance here. But the moment you introduce hydrocarbon, this is the culprit. With this you get PAN, you get ozone, and these are harmful. Let's understand the effects of this photochemical spray. The first, as I told, this ozone and PAN both are harmful and they're powerful eye irritants that will irritate your eyes actually. This ozone and nitric acid will irritate your nose and throat. In the high concentration will cause headache, chest pain, dryness in throat, cough, difficulty in breathing. All these things will happen because of excess concentration of ozone and nitric oxide. This will also lead to cracking of rubber, the tires, and it will also damage the life of the plant. It will also cause corrosion of metals, stones, buildings, paints. All this will happen because of photochemical smog. Now the question is how to control the photochemical smog. See, photochemical smog, mostly it is nitrogen, right, and the hydrocarbons. Correct. So we can control nitrogens and we can control hydrocarbons. Also, the secondary thing that is used is ozone and PAN. We can control photochemical smog, right? Because only it is nitrogen and hydrocarbon which is causing this. So what you can do is you can use some catalytic converter in the automobiles that will prevent the release of nitrogen oxide from the automobiles, and hydrocarbon, because this automobile is a source of NO2 and hydrocarbon. Correct. You can plant some trees which can consume nitrogen oxides. You can do that. There are some trees which consumes nitrogen oxides. So with this we can reduce photochemical smog.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.